When solving two-step inequalities, we're going to both follow the same process that we did for two-step equations and also what we did for one-step inequalities. So we're going to solve the inequality just like we would the equation, but we're going to remember that if we multiply or divide by a negative, we're going to need to flip that inequality sign. And then if we want to, we can check our solution and then graph our solution. And we're going to maybe graph just a couple today, not all of them. When we're solving two-step inequalities, just like equations, we're going to first try to isolate the term that has a variable. So in this first one, that negative 3x, that's the term with a variable. So we're going to try to get that term by itself. So I've got to get rid of this minus 5. We're going to do inverse operations. So then the opposite would be we're going to add 5 to both sides. And this makes 0. Negative 5, positive 5. That should make 0 if we did the right operation. Then I have negative 3x. I did not multiply or divide by a negative, so that's going to stay greater than. And then we add 12 plus 5 is 17. And then now that this term is isolated, now we're going to try to get the x by itself. Right now the x is being multiplied by negative 3. So the opposite is we divide by negative 3. And then because we divided by that negative, anytime we multiply or divide by a negative, we're going to flip that inequality around. So it's going to become instead less than. And then I can't divide this fraction, so I'm going to leave it as negative 17 over 3. Notice when I flip my inequality sign, greater than went to less than, but you don't change it. If it has an equal to part, it has an equal to part when you flip it. If it does not have an equal to part, it will not have an equal to part when you flip it. So that part doesn't change. The second one, this is one that we tend to have a little bit of struggle with. When we've got this giant fraction, the first thing we want to do is to simplify that giant fraction. So I'm going to get rid of this dividing by 5 first. And the opposite of dividing by 5 is to multiply by 5. And when I do this, because dividing by 5 and multiplying by 5 are inverse operations, they're just going to cancel each other out. So then I'm left with that 2x plus 6 is less than or equal to 2 times 5 is 10. So we are multiplying both sides by 5, but they end up canceling out on this left-hand side. So now this looks a little bit simpler to solve, and we're going to follow our rules. We're going to get rid of this positive 6 first by doing minus 6 on both sides. And we have 2x is less than or equal to 10 minus 6 is 4. Divide both sides by 2. We're dividing by a positive 2, so we do not need to flip the sign this time. And 4 divided by 2 is 2. And then we'll just put this one quick on the number line. Now I have 2 in the middle. Put one number on either side. Because it has the or equal to part, we're going to want to fill in that circle. Now values for x that are less than 2, so to the left are the smaller values. The third one, I'm going to do the opposite of plus 1 is minus 1. So we're typically going to add or subtract first, with the exception of on that second problem we have this big fraction. That's the only time we're going to switch the order that we're going to work in. So we're going to subtract 1 from both sides, and then we're going to get x over negative 3, that stays the same, is less than negative 4 minus 1 makes negative 5. We keep the inequality the same so far because I just subtracted 1. It's only when you multiply or divide we're going to flip that, like we're going to do now. The opposite of dividing by negative 3 is to multiply by negative 3. So now we're multiplying by a negative number. That means we're going to have to flip that sign around. So x becomes greater than, and then that's going to give us a positive 15. And then down here, this is where we struggle a little bit with the number on the outside. So the x term is at negative 2/3 x. We're going to save that for last. I've got to get rid of this negative 7 first. And the opposite of negative 7 is a positive 7. Negative 7, positive 7, that should make 0. And then don't forget to bring down that minus sign that's attached to that 2/3. And 3 plus 7, that gives us 10. There's two different ways we can do this one, whichever one makes more sense to you. The negative 2/3 is multiplying by the x, so the opposite is to divide both sides by negative 2/3. But if you remember how to divide fractions, if we divide by negative 2/3, that's really the same thing as saying 10 times the reciprocal, so negative 3 over 2. And if we do it this way, then I can reduce, and we end up with x. We do have to flip the sign because we're dividing by a negative, so greater than or equal to, and we ended up with 15. And the next one is another common error here. This positive sign, this plus sign here, is attached to the 4x. So when I'm trying to get rid of that minus 3, the opposite of a minus 3 is going to be a plus 3. So we tend to want to see that plus sign here and think that we need to be subtracting, but you need to look at what number you're trying to get rid of. Negative 3 and positive 3, this should always make 0 if we're doing the right sign, and this one does. So I need plus 3 on the other side. It's going to give us 12. And then we still have that positive 4x. And we're going to get rid of that multiplying by dividing both sides by 4. It's going to be 3 is greater than x. Now, if I want to, I can flip this one around. A lot of us like to have that variable on the left-hand side. Makes it easier to graph. So we could also make the equivalent expression, or the inequality. So the equivalent inequality is to flip the x and the 3. But if you do that, you have to also flip that inequality sign. So notice up here, this big side faces a 3. Make sure that big side still faces a 3. And the small side faces the x. Make sure the small side still facing the x. So now those are equivalent inequalities. They are showing, meaning the exact same thing. When I graph this one, I put that 3 in the middle, 1 on either side. It does not have the equal to part, so I'm going to have an open circle. And I need values for x that are less than, so I'm going to shade in this direction. So some of you like to use that shortcut to treat this inequality sign like an arrow, which we can do only because the variable is on the left-hand side. And for our last one, we're going to follow the same steps even though they're fractions. So I've got to get rid of that plus 2/5. So the opposite of plus is minus 2/5 to make that 0. So I've got a minus 2/5 over here also. If you have a calculator, you can do that in the calculator. By hand, you need to get a common denominator. So the common denominator between 2 and 5 would be 10. So 1/2 is 5 over 10, and then negative 4 over 10. And then when I subtract, I get 1 over 10 is less than negative x. Don't forget to bring down that negative sign. It's still attached to that x. And then once we do this, there's actually a hidden 1 here, so I can put a 1. So the last thing that's happening is x is being multiplied by negative 1. So the opposite would be to divide by negative 1 and divide both sides by negative 1. That's going to get us at x by itself. Be careful, the x is on the right. X needs to stay on the right. I did divide by a negative though, so because I divided by a negative, that inequality sign has to flip around. And then 1/10 divided by negative 1 is negative 1/10. And then just like before, if I want to make that equivalent inequality, I could flip the whole thing around and say x is less than, make sure that small side still faces the x, make sure the big side still faces the negative 1/10. So we end up with the equivalent inequality, x is less than negative 1/10. And now if I wanted to, I could put negative 1/10, 0, negative 2/10. We're going to have an open circle because it does not have the equal to part. We're shading less than. It's going to go this direction.